Hello dear students, this is lecture series about electromagnetic theory, the Giancoli physics. Okay, now the topic name is series combination of resistors. Okay, so in the series combination, the resistors are connected end to end. You can see that first resistor R1 that is connected, the right end of this resistor is connected to the left end of the resistor R2, and the resistor R2 right end is connected to the left of resistor R3. So the last resistor right end is connected with the negative terminal, and the first resistor left end is connected to the positive terminal. So this is series combination of the resistors. So there are two ways to combine. First way is to combine series combination. Series mean one resistor, then we have two resistor, the second resistor, then we have third resistor, and finally first and last resistors are connected to the with the battery of voltage V. Okay. So in the series combination, the total equivalent resistance or total resistance is equal to total resistance of circuit is equal to R equivalent is equal to R1 plus R2 plus R3. So this is for series total equivalent resistance of series combination. Okay. Now we derive this formula, this equation. Okay. In order to derive this equation, let me explain. For example, if we have a battery of voltage V, okay, now we see that the if current I starts flowing through the battery, total current I flows through the battery. So we can see that the same current I1 that flows through R1, same current that flows through R2, and same current flows through R3, because there is only one way for the current. So the current I1 and I2 and I3 is the same, that is equal to I3 is equal to I, that is the equal, because only the single path for the current. Okay, but we know that the voltage is dropped, because we know that the R1, the energy supplied from positive terminal towards the R1 is different. So the energy supplied by battery to the resistor R2 is different, because every resistance is different. So it means if resistance is different, the voltage developed across each resistance is different. Suppose the voltage developed across R1 is V1, and the voltage developed across R2 is V2, and the voltage developed across R3 is V3. So the total voltage is divided according to their resistance values. So if we add these three voltages V1, V2, V3, so it will give us the voltage, total voltage V. For example, I will explain by a simple example. For example, if we have a 9 volt, for example, R1, the voltage across R1 is 5 volt, voltage across R2 is 3 volt, then the voltage across R3 is 1 volt. So if we add these three, 5 plus 3 plus 1, that will give us a total voltage V. So if these three resistors R1, R2, R3 are the same, so the 3 volt is appear across each resistor. Okay. So if R1, R2, R3 are different, so that the total voltage V is equal to V1 plus V2 plus V3. Now we simply apply V is equal to IR for each case. So total voltage V is equal to current I and the R equivalent total resistance, that is equal to V1. We know that the voltage V1 is equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. So we put IR1 plus IR2 plus IR3. So we get IR equivalent equal to I is common. We take common R1 plus R2 plus R3. So I will be cancelled, and we are left with the R equivalent equal to R1 plus R2 plus R3. R1 plus R2 R3. So this is the total resistance, equivalent resistance of this series combination. This is opposite to the parallel. In the parallel combination, this is opposite to the capacitors. In the capacitors, this is for parallel combination, but for the resistors, this is R equivalent is equal to R1 plus R2 R3. So suppose we have R1, we can find the equivalent resistance by just adding all three resistors. Just adding. For example, R1 is equal to 5 ohm, and R2 is equal to 3 ohm, and R3 is equal to suppose 9 ohm. Suppose. So the total equivalent resistance is just we have to add 5 plus 3 plus 9. So it will give us a total resistance 12 plus 5 17 ohm. So we just add 3 resistance to get the total resistance. Okay, thank you.